Hi, George Romanic here. Welcome to Fundamentals of Weather and Climate. Relative humidity is a variable that is most often used to describe moisture content in the atmosphere to the general public. However, it is often misunderstood quantity, and in today's video I will explain this quantity in details. Relative humidity is what? It is the actual amount of water vapor in the air compared to the maximum amount of water vapor in the air before we have saturation. Let me write it. Now, I purposely used here the word amount. And you will see soon why. Because how do we describe amount, which is kind of qualitative feature? Well, we have option to describe actual amount of water vapor using the partial pressure of water vapor in the atmosphere, and saturation amount of water vapor we can describe using the saturation vapor pressure. So this would be relative humidity, and we often multiply this by 100 so that the results are given in percentages. That's equation for relative humidity. But I also want to tell you that you don't have to use pressures, vapor pressures. That's why I use the word amount here. If you watched properly my videos on the mixing ratio, then you can see that this can also be expressed as the mixing ratio of water vapor divided by the saturation mixing ratio multiplied by 100 again. Or you can also describe relative humidity as the ratio between density of water vapor in the atmosphere divided by the density of water vapor at saturation times 100. So this amount can be in terms of pressures, in terms of mixing ratios, in terms of water vapor density. It can also be in terms of the specific humidity, Q, and so on. But indeed, we most often use this form of equation where we use vapor pressures. So you can see immediately that if E is smaller than ES, then we have unsaturated air. If E is indeed equal ES, we have saturated air. In the case of saturated air, relative humidity is 100%. In the case of unsaturated air, relative humidity is less than 100%. Theoretically, it can also be 0%, but that never happens in the atmosphere. And if E, can it be larger than ES? Yes, it can. I discussed in my video on the saturation vapor pressure that there are transient conditions where partial pressure can exceed saturation pressure, and we call this supersaturated air. And in that case, relative humidity can a little bit exceed 100%. It can be 100 point something, maybe 101%. These are already very high levels of supersaturation in the atmosphere. Okay, so what would mean if we say, for example, that relative humidity is, 70%? How do we interpret this? Well, we can go to this equation and see that 70% means that E is 0.7 of ES. In other words, air reached 70% of saturation value. We can add 30 more % of water vapor at a given temperature before we reach saturation. And now I introduced another important label here, and that is temperature. Because this saturation vapor pressure, you know very well from my video on the saturation vapor pressure, depends on temperature. Very important. Well, because ES depends on temperature, that means that relative humidity also depends on temperature. As for a given amount of water vapor in the air, as the temperature is increasing, relative humidity is decreasing, and vice versa. And that is often one of the reasons people misunderstand this quantity. So in my next video, I will go in depth how you can mess up interpreting relative humidity because relative humidity depends on temperature. In other words, if you keep E constant, the amount of water vapor is constant. You change temperature, you will change relative humidity. How that happens will be discussed in the next video. Until then, goodbye.